All right, new chapter, chapter 10 on circles. So over here, hard to see, sorry for that watermark. Over here we have a circle, and we have different lines connected to it, through it, all sorts of stuff. So we need some vocabulary here. So the first one we have is a chord. All right, the chord's right here. All right. So a chord has both endpoints on the circle. So it goes from here to here. All right. The secant, that's this right here. It's a line. Oh, I forgot to say this is a segment. Sorry. So it starts and ends on the circle. The line for the secant passes through 2 points on circle. So right here and here. So kind of a secant is a chord if you just keep going. Kind of like a line compared to a line segment. Similar idea. The secant just continues. So if I continued this, now my chord is a secant. All right? Similar idea. Now a tangent, that's this one right here. You can see it's outside the circle, and it looks like it's touching from here to here. It's really not. It's only touching at one point. So it's a line that intersects or touches only one point. Yeah, it's very important. It looks like it touches more, but it really only touches right there. Okay. The radius, you've known this one for years, all right? A radius is a segment from the center, I want to abbreviate that, the center to a point on the circle. So radius and diameter are the two words you've known for years. Radius is the halfway and diameter is the full, okay, going through the center. But we have three new ones. So diameter, last one, is a segment, again, passing through the center. With both endpoints on the circle. So in other words, the diameter really is a chord that goes through the middle. All right? All right. So here is all that again, all right? This point we talked about before, the one point where the tangent hits is called the point of tangency. All right, so tell us whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of C. All right, I'm going to give you a little bit better picture here. So AC, it's a segment. AC goes from here to here. Well, that would be a radius. It's going from the center to the outside of the circle. AB goes from here to here, through the center. So that's a diameter. All right. It's also a chord, but the diameter is the best description of it. DE, notice DE is a ray. Okay, it could be a line in this case, but it's this one right here, DE. Well, that is just touching at B. So that's a tangent. AE, well, that's kind of hard to see because of the mess I made, so let's clean this up a little bit. AE is from here to here. Okay, so notice it's going through, it's a line touching the circle at A and G. All right, that makes this a secant. Now we're going to add a couple other ones. AG, just the line segment, is a chord. And F, we'll just go with B, point B, and that is the point of tangency. It's the point where DE touches the circle. Okay, a little bit more vocabulary. Coplanar circles. Coplanar just means on the same plane. So basically on a piece of paper, if you draw two circles, these are the things that could happen. So in a plane, your piece of paper, your desk, two circles can intersect in 2 points right here. Okay, so if you think about a Venn diagram, you've probably made in plenty of classes before. That's you make a Venn diagram, that's 2 points of intersection. So you have the left side, the right side, and that middle section. All right. It can also intersect at 1 point, okay, where one of the circles is inside or outside of the other, and they're just touching at that 1 point, the point of tangency. They're called tangent circles. So like if you were playing, like pool, and you put one ball and put it right up against the other one touching, they are touching at 1 point. Now that's a 3D object, okay? How about two Frisbees? You have two Frisbees lying on the ground. If you push them up against each other, it may look like it's touching in more than one place, but it's actually specifically touching at 1 point. And then you could have no points, all right? Okay, no points, where it's just two separate circles, or maybe you have circle inside of another circle, perfectly, all right, with the same centers. Those are called concentric circles. Last bit, a line or segment that's tangent to two coplanar circles is called a common tangent. So this right here is a common tangent because it's tangent to both the circles. So is this one right here. Right? A common internal tangent intersects the segment that joins the centers of the two circles. A common external does not intersect the segment that joins the centers of the circles. All right, so for example, tell how many common tangents the circles have and draw them. Okay, so what we're doing is we're going to just draw lines where they could possibly touch. So I'm going to do my best job possible. There's a line of tangency. Same idea here. That's a horrible, not straight line, but that line is tangent. You can also form an X where it hits this one here and hits this one there. That's horribly drawn. Let's try it, see if I can do better. Let's see if I can use a straight line feature. There we go. A little bit better. So that one's touching right here and maybe right there. And then the same thing. Whoops. Where this one touches like so. And so maybe, right here and right here. So that's 4. Okay. Then on B, since they're already touching, you have one right here, obviously, and then one there and one there. Those are horrible. I apologize. So that's 3. And then on this last one, it would just be these two. Oh, sorry, it says use a blue line to indicate common external tangents and a red to indicate common internal. So I should have changed those colors up, sorry. So since I messed up, let's just label them. So this one's internal, this one's internal, external, external. This one's internal, external, external, and these are both external. Okay, and internal, you know, it's in between them. That's an easy way to remember it. Sorry about that. All right, some theorems. Can't have a unit without theorems. So, tangent line to circle theorem. In a plane, again, your piece of paper, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle. So when it touches at this one point, right there at P, it is going to be perpendicular to a radius. Now, there's a lot of radii, you know, in this circle, but only one is perpendicular to that tangent line. And then the external tangent congruence, tangent segments from a common point are congruent. So when you have a point out in space, like I could do it way out here, and if I draw a line from here to there, just touching, and there to there, just touching, let's call this Q, these are going to be congruent. These are congruent. So if you're coming from a common point, all right, and coming in, then you have congruent lines. So is ST tangent to point P? Okay, well, to do that, this has to be a right angle. And the way we prove it's a right angle is our good friend Pythagoras. So again, here is my hypotenuse. If it's a right angle, that means this is A and B. So let's do A squared plus B squared equals C squared. So 12 squared plus 35 squared equals 37 squared. And we get 1369 equals 1369. So that's a true statement. So yes, perpendicular. So yes, tangent. If you ever need to hit pause, go ahead and do that. All right, in the diagram, point B is a point of tangency. So we know this is a right angle right off the bat. We don't even have the numbers yet. So find the radius of C. So it's going to require a little tricky math. So we're going to still use Pythagoras. It's just going to be a little harder than we've ever done before. Just more work. So this right here is my hypotenuse. Okay? We don't know what R is. So my hypotenuse is 50 plus R squared. Actually, sorry, I'm going to write R plus 50 for what we're doing next. All right? That is the hypotenuse. Now, there's my A and there's my B. So it's just R squared plus 80 squared. All right? So that's just R squared. 80 squared is 6,400. And this is going to be a little bit of work. So remember, this is R plus 50 times R plus 50. So we're going to do first times first. Outer and inner is going to be 50R plus 50R. And then last, 2,500. Okay, so when I simplify this, I'm going to give R squared plus 100R plus 2,500. Now, it's not going to be as scary as it looks because when I subtract R squared, that makes those go away. So I'm left with 6,400 equals 100R plus 2,500. Well, now I just want to get R by itself, so I'm going to subtract 2,500. So that gives me 3,900 equals 100R. And then when I divide by 100, I find out that my radius is 39. So a little trickier than we've done before, but that's how you do it. And it's just using the skills you learned from Algebra 1. All right, last example. RS is a tangent. Okay, well, if it's tangent, that means this is equal to this. So I simply just set up 3x plus 4 equals 28. So I'm going to minus 4 from both sides. 3x equals 24. Divide by 3, and x equals 8. And that's all it wanted me to find was x. Now I can plug that in and check. 8 times 3 is 24, plus 4 is 28. I'm good to go. And that's it.